Hi there, good morning. My name is Alice, and I'm coming in from Hunter College in New York to Dallas, Texas at EarthX conference here with Prahalad. Could you introduce yourself?
Hi guys, my name is Prahalad Gopalakrishnan. I am a 16-year-old student in high school. Fortunately, I got introduced to the TAMS program, so I'm a college freshman.
Okay.
I do a lot of work in sustainability. I run a sustainability nonprofit where we do education and sustainability. We go reach out to schools, do things like that. We've served over 10,000 students over the years, and I'm also with a few co-founders running a new startup in sustainability where we create thermal buffering polymers to increase efficiency and decrease heat of solar panels.
Yeah, so sustainability regarding climate restoration, correct?
Yes.
Well, that just so happens to be the elephant in the room. Yeah, you see it, that was smooth, right?
So smooth.
Yes, and so that is to discuss climate restoration, which is basically the goal to reach safe pre industrial levels of carbon in the atmosphere, which doesn't mean just slowing emissions, but also taking away the 1 trillion tons of legacy carbon dioxide in the atmosphere. Yeah, so can you tell me a bit more about what's currently being done in regards to restoring climate?
So a lot of my knowledge comes from different like readings and also coming to EarthX. I found some really cool innovations such as bringing using phytoplankton and bringing them back into the ocean and trapping them underneath the thermocline layer.
How does that
Um,
work?
I believe they add iron to the ocean, and the iron allows for phytoplankton growth, and it captures oxygen, and then the dead phytoplankton sink below the thermocline, so that allows for oxygen trapping.
Hmm.
Again, I think a lot of the new innovations that were coming aren't from your conventional carbon credits,
Okay.
but from unique sort of perspectives that people have toward, hey, how can we reduce carbon not by making other people do it, but by doing niche and small innovations?
Wow. And so, besides this ocean iron fertilization that I'm hearing, what other innovations are you referring to?
One other one that I found extremely interesting was oh, this is really interesting. It's actually something that I'm working on. It's nitrogen reduction. Nitric oxide is a very dangerous pollutant in the atmosphere. It's not your regular carbon dioxide sort of pollutant. It's actually worse. It's the worst greenhouse gas, and it produces acid rain, smog, and lung disease.
Wow.
And so what we do is we found out that the one thing farmers and the community love is ammonia. It is the chemical that runs this country. And my PI, Dr. Kandari in UNT, we run research to reduce nitric oxide to ammonia
Mhm.
using common catalysts like iron and different chemicals so that you don't have to put in any energy. You just capture one of those nitric oxide bubbles,
Mhm.
and if you put it in the solution that we found, it'll create ammonia from it, which allows the industry standard. You're just having ammonia with by reducing this carbon footprint and nitrogen footprint we have on the atmosphere.
Oh, wow. I see. If you could rephrase that in more layman's terms, how would you? Uh,
I would say I would, s- we take nitrogen oxides, which is a dangerous compound, into a solution or a generator, and we don't have to power it because it is favorable and it'll automatically rearrange to form ammonia. And a lot of my work I do is I make sure that we map out each step so that it's environmentally friendly. So
mhm.
there isn't any unwanted side effects and things like that. Right now, the current way of producing ammonia causes a lot of CO2 to go to in the atmosphere, as well as like hydroxylamines and different materials. And our method is like, hey, the current method, the Haber-Bosch process, produces 20%
Mhm.
ammonia. Ours produces maybe 50%. And it's a lot more efficient. And these are the sort of innovations I'm talking about. Things that aren't reinventing stuff we know, but improving. We're increasing efficiency. I like the phrase, you can't invent something in a day. You
Mhm.
can't change the world in a day. You got to make steps and transitions. And I think that's what the industry is moving toward.
Absolutely. So it seems like you're really on board with the innovation process and kind of contributing engineering and I guess environmental science into your work. Where in the world is this project most important to? What's your target audience?
So with nitrogen oxide, we, me and my professor, were mostly doing it in academia as a proof of concept.
Right.
But to target it, I would say anywhere with heavy smog.
Hmm.
So New York, Boston, China, India, those metropolitan areas. In India, I would say like Chennai, Delhi, in China, Beijing. All of these heavy metropolitan areas that have a lot of gas,
Hmm.
that's where you want to put these because also these countries, if you move maybe 100 miles south, you have farmland that needs this ammonia for production. And if you're able to make this perfect transmitting property, you can make it so that you're removing nitric oxide from one area and then putting ammonia back in the soil in another place.
Oh, okay.
And then for the other project that I'm working on, which is Daedalus Slabs, that's our thermal buffering polymer,
Hmm.
we're focusing more on the equatorial regions because that's where solar panels heat up a lot. And when solar panels heat up a lot, you're losing a lot of the efficiency that you have. And so what we're doing is we're like, hey, if your solar panel's heating up, we can fix that without using heavy current, heavy water usage, anything like that. You just put in our polymer in the back, and then there you go.
Yeah, I hear that when it comes to solar panels, that sometimes some unintended side effects are that it makes the land surrounding them infertile or unfertile for plants to grow, and so it's also creating a toxic landfill, arguably. What are your thoughts on that?
I think that that is a very important thing to consider. The reason that solar panels do that, one, there are many downsides, I think, of when we talk about solar panels. A lot of people talk about all of the positives, but I think it's important to talk about the negatives, right?
Yeah.
Solar panels, they don't, and this is a common misconception, they don't use rare earth metals, but they do use alkali earth metals. And no matter what, alkali earth metals or any metal is from mines.
Hmm.
And so, because of mass producing solar panels, you are going to be mass producing mines and minerals for this. At the same time, as stuff heats up, which is especially where I'm working,
Hmm.
things degrade faster. And so, if a solar panel is supposed to last 10 years, maybe it'll only last 5 in an equatorial region. And that's a big concern. And that contributes to the waste cycle. Because if I'm having to replace solar panels every 5 years, that's not great.
Hmm.
And whenever you're putting solar panels on like a surface, you don't get to do anything else on them. You can't do agriculture. You can't use it for anything else. The
Right.
only thing you can use it is for underground storage or underground mining, which that in return isn't a great thing.
Yeah.
People now are looking at setting solar panels in space, doing things like that, and I think those are really interesting innovations. This is not a usually common thing you hear at EarthX or in any sustainability conference, but I think what we're doing is we have to choose between the lesser of two evils.
Mm.
We're at a position right now where going and doing nothing is going to put us in a worse state as doing something that is slightly more sustainable but not fully sustainable. Solar panels are not the final solution. They're not the solution that we can argue will make the world sustainable. But it is the solution that we can take to transition ourselves away from being a carbon positive planet.
And about like choosing between the best of two evils, I could definitely imagine some youth being deterred from the topic entirely due to having to make this decision. Do you have any words of wisdom or encouragement to have the next generation pay attention to climate restoration?
You can't see the cake and eat it. I think that's the thing, right? If you want to do something sustainable, I can't just be talking about it. I have to do it. And
Mhm.
at the same time, you can't expect to be a magician. You can't expect to have a hat and pull out an elephant from it. No,
Yes.
you got to construct it, right? You got to make it happen. And when you're looking at this, I think if you go back hundreds, even thousands of years, you'll see that all innovation comes in steps.
Mhm.
There was never an innovation that just appeared out of nowhere. Even our current internet, modern AI, or anything like that, it's building blocks. Right now, you and I see the final products,
Mhm.
but if you cast our minds back, you see that everything's based on innovations. And if you're watching and you're youth, you should take advantage of that. Go innovate. You're not going to get it right the first time. You're not going to get the perfect solution right the first time, but you're going to get some solution. And I think what we need right now is we need some solution that we can grow. For example, in my work with Dadulus Labs, we don't have the perfect solution. Our module is great. We are cooling 5 to 15 degrees Celsius, and it's wonderful, but there are a lot of changes that we can make. The biggest thing that I would say is do not allow failures to stop you, and don't allow perfection to stop you either. Perfection doesn't exist in the industry. You got to keep innovating, and you have to start innovating now and not push yourself to perfection.
Lovely. Thank you so much for your time.
Of course, thank you.
Yeah.